Now we will learn in how to use a Poisson distribution probability. We start with its definition. Like binomial distribution is a discrete probability model used to describe how often an event occurs within a fixed period of time or a specific region of space. It is appropriate when events happen independently and the average rate of occurrence, mean, which is the lambda, is known and remains constant. This distribution allows us to calculate the probability of observing exactly X occurrence of an event within the given interval. It is commonly applied to situations involving rare or random events such as the number of phone calls at a call center per hour, printing errors per page, or accidents on a particular location. In short, when event occurs randomly but with a predictable average rate, the Poisson distribution provides a reliable way to model and analyze the number of occurrences. So now the word average here is a good indicator to use Poisson distribution probability when you read the question. I say this because this is very important to know, as in a real exam question, at least in my country, they will definitely combine all distribution in one question and students always struggle which distribution to use. Next, we try looking at the formulas. This is Poisson distribution. Lambda represents mean number of events occurring within a fixed period of time or a specific region of space, while X is a random variable X follow Poisson distribution with parameter lambda. So on instance of exactly X value, this is the equation used with its X value is a discrete, meaning only whole number. Since we already established mean number of event is the lambda, so obviously mean equals to lambda, as well as its variance also equals to lambda. So this is the stat table for Poisson distribution that will be used throughout our example and exercise. This is cumulative Poisson probability. The table is based on X less than or equals to X. This is just some of the numbers from the table. You may refer to a whole stat table online, but remember to look specifically for cumulative Poisson probability distribution. If you not, you end up with the wrong table. So if you're a student taking statistic watching this, you may already have a stat table book provided by the universities. So with that out of the way, let's look at the example. We start with very basic. So given X, Poisson lambda 1.9, question 1 is P X less than or equals to 4. Very straightforward. So let's look at the table here. I will only teach how to read the stat table once. So our question asking for X less than or equals to 4. X is 4 here and the lambda is 1.9. So the final answers will be 0.9559. So the answer 0.9559. Question 2 is Px more than or equals to 2. In graph form, it should look like this. You see here, more or equals to 2, meaning the graph have to include 2. So, this is what we want. Since the stat table use cumulative, so we only have less than or equal for number data. So what we do is we take from here, we take whole one probability like this. This is equals to 1. 1 will be part of our calculation. For our final graph, we want the above. So next, we will do the removing. So we remove under 2. Here, we remove under 2. In our calculation, it become minus E x less than or equals to 1. So y1, since it's a Poisson, is a discrete. Poisson is a discrete. So there is no numbers like the in between here, like 1.1 or 1.5 between the 1 and 2. So we consider this as 1. Okay, remember in binomial distribution video, I make the in between 1 and 2 is equals to 2. Well, technically, it doesn't matter, but mathematically, it's kind of wrong. Because in graph, it doesn't matter if it's 1.5 or 1.9. It's still not the number 2. But if you still want to use what's been learned in those videos, you can. Just that the way you remove the number will be slightly different, but still get the same conclusion. Just want to clarify. Yeah, it can be confusing, and it's preferable if you can do it without the help of the graph. Good for those that can, but some students have a hard time imagine or understand it. So I try to provide the graph to help with the visualization. Now let's resume. 1 minus E x less than or equals to 1 from the stat table. It is 0.4337. So the answer is 0.5663. Question 3. E x less than 6. So this symbol means not including the 6. So the answers 1, 5, 4 until 0. So the answer is P x less than or equals to 5. From the stat table, the number is 0.9868. Question 4. Is x more than 6? The same question as number 3, but the answers 1, 7, 8 and beyond. So the graph should look like this for x more than 6. Again, 6 not included because more than 6. So to get this, we take a whole one and then remove the under 7. So it will become minus E x less than or equals to 6. Now we can solve the question. So 1 minus from the stat table, it's 0.9966. So the answer is 0.0034. Question 5. X equals to 5. So we can just use the formula for the equation. So we have lambda, which is 1.9, and x is 5. So just insert the numbers. So the answer is 0.0309. Next, we can try real exercise. So question is, in bustling city of St. Justicia, Skyline Builders has been tasked with constructing playgrounds for new residential district. On average, they can complete 5 playgrounds every 6 weeks. Find the probability that in 6 weeks, only 2 playgrounds are complete. So first, extract the information from the question. So it mentioned on average, meaning that we will use Poisson distribution. So the average is 5, meaning that lambda is equals to 5. We write down the Poisson distribution. So this distribution is for when they complete 5 playground every 6 weeks. 6 weeks. Now we have all the info. Let's look at question 1. Again, it's in 6 weeks, only 2 playgrounds are completed. So only 2 meaning X equals to 2. And in 6 weeks, so we can proceed using this Poisson as it's also for 6 weeks. So using the formula, the answer is 0.0842. So question 2, in 6 weeks, at least 8 playgrounds are completed. So at least 8 means X more than or equals to 8. So from the graph, must include the 8 and the above. So to get this, we take the whole one to 1 here and then remove the under 8 from the graph. So we get minus X less than or equals to 7. So 1 minus 0.8666 from stat table, and the final answer is 0.1334. Question 3. In 3 months, more than 20 playgrounds are complete. Here, unlike the previous question, where it already wants to find the probability in 6 weeks, and the question already given you the info. But here, it gives us a different time. So what we want to do is make a new one. So I write the original distribution. X, Poisson, lambda 5 for 6 weeks. And I just put in Y, Poisson, We don't know the lambda number yet, so I put in unknown A. So this is for 3 months. So we can convert 3 months to weeks or 6 weeks to months. So just so that we want to have like both of these in a same type. In this case, we choose to convert 3 months to weeks. Generally, 1 month have 4 weeks. So in 3 months, 3 times 4 equals 12 weeks. So 3 months have 12 weeks. Now we can find the A. So the sure way to get it is by doing it like this. Take this. So 5 equals 6. A equals 12. We follow this sequence. A times 6 divided by 5 equals 12. It will look like this. A times 6 divided by 5 equals 12. So solve the equation and we will get A equals to 10. Now finally, we can answer the question with the newfound Poisson distribution for 3 months or 12 weeks. Yes. So question 3 asks for more than 20 playground. So P, why more than 20? So the graph should be looking like this. So more than 20 meaning 21 and above, not including the 20. But to get this, we take the whole one, and then remove the under 21. So it will be minus P y less than or equals to 20. Now we solve the equation. So 1 minus 0.9984 from the stat table, and the final answer is 0.0016. So finally, in exercise 2, traffic data from a Statistic district shows about 12 vehicles passing through in a 1.5 hours period. What is the probability that more than 6 cars passing through in 30 minutes? So we extract the information. So 12 vehicles passing through in a 1.5 hours period. We know from here the lambda is 12. Plus 12. So Poisson distribution is X. Poisson 12. This is for 1.5 hours. The period taken for 12 vehicles to pass through. Since the question asks for 30 minutes, why? Poisson lambda is unknown, so we put in A. So this is for 30 minutes. So next step, we either change 1.5 hours to minutes, or we change 30 minutes to hours. This time, we choose to change 1.5 hours to minutes. So we know we know 60 minutes is equals to 1 hour. So what minute it will be for the 1.5 hours? So we can also use the same method like we put in B here. So we times here and divided by 60. Do like this. It will look like this, equals to 1.5. So B equals to 90 minutes. So now that we know 1.5 hours is the same as 90 minutes, we use the same method as before to solve this as well. So 12 equals 1 as 90 minutes and A equals 30 minutes. So times here divided here. So it will look like this. Divided 12 equals 30. So A will be equals to 4. So finally, we can solve question 1 with the new Poisson Y. Poisson 4 for 30 minutes. It wants more than 6 cars passing. So P Y more than 6. So more than 6 mean not including 6. So it wants 7 and above. So in graph, it should be looking like this. So to find this, we take a whole 1. We take a whole 1 to 1 here and get rid of less than 7. So it become minus P Y less than or equal to 6. So solve the equation and we get 1 minus 0.8893. So from the stat table, and the answer will be 0.1107. So question 2, at most 13 cars passing through in an hour. We write back the original Poisson. So since it's for 1 hour, we can make a new Poisson. So Y, Poisson unknown A for 1 hour. So no need to change any of these as both are already in an hour format. So 12 equals 1.5 and A equals to 1. Use this method. So A times 1.5 divided by 12 equals to 1. Solve the equation and we get A equals to 8. So the new Poisson is Y Poisson 8 for 1 hour. So the question asks for at most 13 cars. So that means that less than or equals to. So P Y less than or equals to 13. So from the stat table, the answer will be 0.9658. So final question is between 9 and 16 passing through in 1.5 hours. So it asks for 1.5 5 hours, so we can use the original Poisson. So it has between 9 and 16. So it will look like this. Since it is between, so it wants x is 10 until 15. Draw the graph. So to get this, we take the highest number first, which is 15. We take this, and then this means that this is p x less than or equals to 15. Now we want to get rid of below 10, which is we get rid of this. So that means it will become minus p x less than or equals to 9. Now we can solve the equation. So using this stat table, it will become 0.8444 minus 0.2424. So the final answer will be 0.602. And that's about it. I hope you managed to understand about the Poisson distribution probability and how to solve it. Thank you for watching.